Frequently missed homework questions from Unit 3, Part 2. We did this in class on Thursday, December 3rd, or Friday, December 4th, depending on what hour you're in. So the first question is from the applications topic. So whenever we have word problems like this, make sure you're either highlighting or underlining your problem. So it's talking about someone draining water out of a bathtub, and it says there are 50 gallons of water in the beginning, and then it decreases at a rate of 6 gallons per minute. And what we want to do is write an equation to represent the relationship between the amount of water in the tub and the number of minutes it has been draining. So as you can see in this example, it gives us what variables we want to use. If it doesn't give us what variables, you are more than welcome to just use x and y. Okay, so we want to write an equation for the amount of water in the tub W. So the amount of water in the tub is going to be equal to how that water is made up. Well, we are starting with 50 gallons. Okay, so we're starting with 50 gallons and then we're decreasing water. So if we're decreasing water, we need to subtract from that 50. And we're subtracting at 6 gallons per minute. So we would have 6 gallons multiplied by how many minutes the water has been draining. So we would write this equation as W equals 50 minus 6m. Or you can write it as W equals negative 6m plus 50. Whichever one you want, they both are fine. Just make sure you have the negative in front of that 6 and that 50 is positive. And this is in slope-intercept form. Okay, our next question, talking about the progress of plant growth. So today, the plant is 5 centimeters high, and then the plant grows 1.5 centimeters per day. So we want to write an equation that represents the height h after d amount of days. So again, it's given us our variable. So we're going to have the height equal to, well, it's starting at 5 and then it's growing. So if it's growing, we're going to add the amount it's growing, and it's growing at 1.5 centimeters per day. Okay, so since it's growing 1.5 centimeters per day, we need to multiply the amount of days times 1.5. So we can write it like this, or you are more than welcome to write it as h equals 1.5 times d plus 5 as well. Okay, either of those would be fine. So our next question, what will the height of the plant be after 20 days? Well, we know D represents the amount of days, so all we need to do is put 20 in for D, and then we can solve for the height. Okay, so we would have H equals 5 plus, and then we take 1.5 times 20, which is 30, and then we still need to add on this 5, so H is 35. So after 20 days, the plant will be 35 centimeters. Okay. Looking at parallel and perpendicular lines now. So it first asks us, what is the slope of the line y equals 4? Well, first let's graph y equals 4. Okay, well, if we look at our y-axis, okay, we can see if we go up 1, 2, 3, 4, y equals 4 right there, but y equals 4 is the equation of a line. It's not just a point. Okay, so our line would go through all the points where y equals 4, and my line got a little messy there. So we want the line y equals 4. There we go. Okay, So anywhere on this line, no matter what point you pick, it doesn't matter what the x value is, y is always going to be equal to 4. So when we have y equals something, we have a horizontal line. Okay, now if we want to figure out the slope of y equals 4, well, we have rise over run, change in y over change in x, and it's not rising any, but it's running any amount. If you go from any point to any point, there's going to be no change in y, but there's always going to be some change in x. Well, if you take 0 divided by anything, you just get 0. So our slope would be 0. Okay, then if we want the equation of a line that is parallel to y equals 4 and it goes through the point 2, negative 6. First I'm going to graph the point 2, negative 6. Do that in different color, sorry. Okay, if I want a line that is parallel to a horizontal line, then I'm going to need another horizontal line. So my line is going to be horizontal so that it's parallel, and then it goes through the point to negative 6. And since I have another horizontal line, it's going to be y equals again, and then every single y value on this line would be negative 6. So my equation would be y equals negative 6. Okay, what is the slope of the line y equals negative 5? Let's draw that so we have a visual. Okay, and again we have a horizontal line, so the slope is 0. What is the equation of the line perpendicular and goes through the point to negative 6? Okay, well, if it's perpendicular, then it's going to cross our first line and it's going to have a 90-degree angle. So any line that is perpendicular to a horizontal line needs to be vertical. So I'm going to have a vertical line at the point 2, negative 6. And if I have a vertical line, then every single point on this line, x is going to be equal to 2. It does not matter what the y value is, x equals 2. Okay, so we get the 2 from our point. And up here we had y equals negative 6. We got that y value from our point. Okay, so if we have a vertical line and we want to find a line parallel, we would need another vertical line. Okay, residuals, this is from scatter plots. Okay, so if the point is above the line of best fit, the residual is positive. If you did not remember this, you might want to write it down. If the point is below the line of best fit, the residual is negative. So remember, the residuals are the vertical distance between the point on the scatter plot and the line of best fit. So if the point on the scatter plot is above the line of best fit, the residual is going to be positive. If the point is below the line of best fit, the residual is going to be negative. So I'm going to work through one of these with you. So if I'm looking at, let's say I'm looking from 0, 0 to my line of best fit. Well, 0, 0 is vertically 1 away from my line of best fit, and my point is below the line of best fit. So my residual would be negative since it's below the line, and then 1 since it's 1 space vertically away from the line of best fit. Okay, if we look at another one, if we look at 6, 5. 6, 5, that point is above the line of best fit, so my residual is going to be positive. And again, it's 1 away, so my residual here would be 1. Okay, I had a lot of questions on this problem since it used the word domain. Okay, remember domain is just x values. So we have a piecewise function graphed. We're going to use the image to determine the value of the function at each domain value. So what this is saying is determine the y value when given the x value. So really each number here is your domain value. It's an x value. So if I were to read this, it's saying f of -1. So what is the output of the function when I have x being equal to -1? So the first thing I'm going to do is I'm going to look at my graph, and on my x-axis I'm going to find -1. Okay, -1 is right there. Now I need to find the y value of the piecewise function. Well, I can do that by finding the point. Okay, on this function, I have the point, whoops, -1, -3. So f of -1 would be -3. It's the y value when x is -1. So I'm going to do one more. So let's say I want to find f of 2. Let me do that in a different color. Well, maybe. Okay, f of 2. Okay, so I'm going to find 2 on my x-axis, and then I'm going to find the point that corresponds with it. Okay, so my point is over 2 up 3. So then my answer would be 3. And those were some of the most missed problems on your homework from Unit 3, Part 2.